This is part 2 of the dual voltage source and DC bias lab activity introduction, and we'll be taking a look at the DC bias portion of the lab. The DC bias portion of the lab consists of figure 4, figure 5, and figure 6. If you take a look at figure 4, see that we've got a DC source that's going to be set at 5 volts. And we have an AC source that's going to be set at 10 volts peak to peak at 100 hertz. And then we're going to take a look with an oscilloscope across RL in order to see the combination of the DC and AC source. This will be a AC signal riding on a DC level. Now we're going to use a separate DC power supply for this portion of the lab because it's more visual, but actually a signal generator generally has a DC offset control on it that will automatically add the desired DC level. Let's take a look at the circuitry. Okay, now this lab is designed to be used by an oscilloscope that's not isolated from ground, where the black lead of the scope is connected on to earth ground through the power system. Also, using a signal generator that's not isolated from ground, where the black lead is connected onto the power system ground. Now this does not present a problem as long as all ground leads are connected to the same point. It does present a problem if they're not, which is something we'll illustrate a little bit later. Okay, so in the first part of the lab here, you're adding together a 5 volt steady state DC value and a 10 volt peak to peak AC value. What you should end up with is a 5 volt DC level and a 10 volt peak to peak signal combined together, which can be represented by saying it's a 10 volt peak to peak signal riding on a 5 volt DC level. Now remember, in order to see this on your oscilloscope has to have the DC coupling switch set of DC coupled, direct coupled, to see both the AC and DC components. Next, you're going to switch around the polarity of the DC power supply and see that you can have an AC signal riding on a negative DC voltage level. Then you're going to take a look at a ground loop problem. If you change around the generator and the DC power supply, you'll have a ground loop problem because the generator's black lead and the black lead of the oscilloscope are connected together through the power system. This shorts out the DC power supply. You'll see the red light come on the DC power supply, and you'll see no DC level on the waveform across the resistor because the DC power supply is shorted out. This is very undesirable, and it happens quite a bit in industry where you have a ground loop problem. Very difficult to find because it's not a physical wire that you can see. You can solve this problem by using an isolation transformer. If you plug the oscilloscope into an isolation transformer, which is a 1-to-1 transformer, the voltage is the same going to the oscilloscope, but it removes the ground from the system. We'll learn more about this later. Now, the very last portion of the lab, we're just taking a look to see if you have a signal that's riding on an DC level. Can you measure the DC component separate? Can you measure the AC component separate with a meter? You probably will not be able to do this last portion unless you have a true RMS meter. True RMS meter will measure the combination. That concludes the introduction.